Cinder concrete is a type of lightweight concrete manufactured using cinders. Cinders are the burnt remains of coal or coke. The porous nature of cinders creates air pockets within the concrete mix. These air pockets reduce the overall density and improve the insulation properties of the concrete compared to standard concrete mixtures. Regarding the installation of electrical metallic tubing, or EMT, stubbing up from concrete, the National Electrical Code permits this practice. However, proper support is essential at the point where the conduit extends from the concrete. This support can be achieved through the use of conduit hangers or straps, which provide mechanical stability and prevent stress in the conduit system. The NEC does not mandate the use of raintight connectors for EMT encased within concrete. However, the use of raintight connectors is highly recommended in outdoor or wet locations. The purpose of raintight connectors is to prevent moisture ingress into the conduit system, which can cause corrosion and electrical faults. Set screw connectors, while suitable for dry indoor environments, are not designed to be raintight and should not be used in locations exposed to moisture. Therefore, the selection of appropriate connectors should take into account the environmental conditions to ensure the long-term reliability and safety of the electrical installation. To elaborate on electrical metallic tubing installation, consider several important factors to ensure compliance with the National Electrical Code and best practices. Firstly, conduit fill is a critical aspect. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. This is to ensure adequate heat dissipation and prevent damage to the conductors during installation and operation. Refer to NEC Chapter 9, Table 1 for conduit fill requirements. Secondly, bending EMT requires the use of appropriate bending equipment to avoid kinking or damaging the conduit. Proper bending ensures that the internal diameter of the conduit is maintained, allowing for smooth wire pulling. The NEC specifies minimum bending radii to prevent damage to the conductors. Thirdly, when cutting EMT, it is essential to ream the cut ends to remove any burrs or sharp edges. These burrs can damage the conductor insulation during wire pulling, leading to potential short circuits or ground faults. A reaming tool is specifically designed for this purpose. Fourthly, grounding and bonding are crucial for electrical safety. EMT can serve as an equipment grounding conductor, providing a path for fault current to return to the source. Proper grounding ensures that metallic parts of the electrical system are at the same potential, minimizing the risk of electric shock. Use appropriate grounding connectors and follow the NEC requirements for grounding and bonding. Fifthly, support requirements for EMT are specified in the NEC. Conduit runs must be adequately supported to prevent sagging or displacement. The NEC provides tables specifying the maximum spacing between supports based on the size and type of conduit. Using the correct support hardware and spacing ensures the mechanical integrity of the installation. Sixthly, when installing EMT in corrosive environments, consider using corrosion-resistant coatings or materials. The NEC addresses the protection of electrical equipment and wiring in corrosive environments. Special coatings or stainless steel EMT may be necessary to prevent corrosion and ensure the longevity of the installation. Seventhly, expansion fittings are required when EMT is installed in locations subject to significant temperature variations. Temperature changes can cause the conduit to expand and contract, potentially damaging the conduit or connected equipment. Expansion fittings allow for this movement without placing stress on the system. The NEC specifies when and where expansion fittings are required. Eighthly, when running EMT through fire-rated walls or floors, fire-stopping materials must be used to maintain the fire rating of the barrier. Fire-stopping materials prevent the spread of fire and smoke through openings in fire-rated assemblies. The NEC requires the use of approved fire-stopping materials and methods. Ninthly, proper selection of lock nuts and bushings is essential for making secure and reliable connections. Lock nuts are used to secure conduit to enclosures, while bushings protect the conductors from abrasion as they enter the enclosure. Choose lock nuts and bushings that are compatible with the size and type of conduit being used. Lastly, always inspect the completed installation to ensure that all connections are tight, supports are in place, and the system is properly grounded and bonded. A thorough inspection can identify potential problems before the system is energized, preventing costly repairs and ensuring the safety of the installation. The National Electrical Code, or NEC, provides specific guidelines for the installation of electrical metallic tubing in various environments. These guidelines are designed to ensure safety and prevent electrical hazards. Consider the installation of EMT in wet locations. According to the NEC, when EMT is installed in wet locations such as outdoors or in areas subject to moisture, raintight fittings are required. Raintight fittings are designed to prevent water from entering the conduit system, which can cause corrosion and electrical faults. The NEC specifies that all fittings used in wet locations must be identified for use in such environment. Next, the installation of EMT in hazardous locations requires special considerations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC classifies hazardous locations into different classes and divisions based on the type and likelihood of the hazard. In hazardous locations, EMT must be installed in accordance with the specific requirements for that location. This may include the use of explosion-proof fittings and sealing fittings to prevent the propagation of explosions. Also, the NEC addresses the installation of EMT in underground applications. When EMT is installed underground, it must be protected from corrosion. This can be achieved by using coated EMT or by encasing the conduit in concrete. The NEC specifies the minimum burial depth for underground conduit installations. Then, the installation of EMT in concrete slabs requires careful attention to detail. When EMT is installed in concrete slabs, it must be properly supported and protected from damage during the concrete pouring process. The NEC specifies the minimum concrete cover required for EMT installed in slabs. After that, the NEC provides guidelines for the installation of EMT in suspended ceilings. When EMT is installed in suspended ceilings, it must be supported independently of the ceiling support wires. The NEC specifies the maximum spacing between supports for EMT in suspended ceilings. Furthermore, the installation of EMT in elevator shafts requires specific precautions. Elevator shafts are considered to be wet locations, so raintight fittings are required. The NEC also addresses the grounding and bonding requirements for EMT in elevator shafts. Additionally, the NEC provides guidelines for the installation of EMT in healthcare facilities. Healthcare facilities have unique electrical requirements to ensure patient safety. The NEC specifies the types of wiring methods that are permitted in patient care areas. The NEC also addresses the grounding and bonding requirements for electrical systems in healthcare facilities. Moreover, the installation of EMT in industrial facilities often involves exposure to harsh environments and heavy equipment. The NEC provides guidelines for the installation of EMT in these settings to ensure safety and prevent damage. The NEC also addresses the use of EMT as an equipment grounding conductor. When EMT is used as an equipment grounding conductor, it must be installed in accordance with the NEC requirements. This includes the use of approved fittings and connectors to ensure a continuous and reliable grounding path. Finally, always consult the latest edition of the National Electrical Code for the most up-to-date requirements for the installation of electrical metallic tubing. The NEC is a comprehensive set of standards that is updated regularly to reflect changes in technology and best practices. Proper installation of EMT is essential for ensuring the safety and reliability of electrical systems. To further understand the requirements for electrical metallic tubing, or EMT installation, let's examine several specific sections of the National Electrical Code, or NEC. Firstly, consider NEC Section 358.10, which covers the uses permitted for EMT. This section outlines the types of locations and applications where EMT is allowed to be installed. It generally permits EMT in both concealed and exposed locations, subject to certain restrictions. Secondly, NEC Section 358.12 details the uses not permitted for EMT. This section specifies locations or conditions where EMT is prohibited, such as in areas subject to severe physical damage unless properly protected. Thirdly, NEC Section 314.40 addresses the support of boxes and conduit bodies. It requires that boxes and conduit bodies be securely supported to prevent them from being dislodged or damaged. This is particularly important when EMT is connected to boxes or conduit bodies. Fourthly, NEC Section 300.11 covers the securing and supporting of wiring methods. This section provides general requirements for securing and supporting all types of wiring methods, including EMT. It specifies the maximum spacing between supports and the types of support hardware that are permitted. Fifthly, NEC Section 250.118 lists the types of equipment grounding conductors that are recognized by the NEC. EMT is listed as an acceptable equipment grounding conductor under certain conditions. Sixthly, NEC Section 300.12 addresses mechanical continuity of raceways and cable. It requires that raceways and cables be installed in a complete and mechanically sound manner to ensure electrical continuity. Seventhly, NEC Section 314.16 provides rules for calculating the number of conductors permitted in boxes. This is important to ensure that boxes are not overcrowded, which can lead to overheating and other problems. Eighthly, NEC Section 358.42 covers bushings. When EMT enters a box or enclosure, a bushing must be provided to protect the conductors from abrasion. The bushing must be properly sized and installed to provide effective protection. Ninthly, NEC Section 300.4 addresses protection against physical damage. Wiring methods must be protected from physical damage that could compromise their integrity. This may involve the use of conduit guards or other protective measures. Lastly, NEC Section 110.3 provides general requirements for the examination, installation, and use of electrical equipment. Electrical equipment must be installed in accordance with its listing and labeling and must be used only for its intended purpose. In addition to these specific NEC sections, it is important to consider local codes and regulations that may apply to EMT installations. Local codes may impose additional requirements or restrictions beyond those specified in the NEC. Always consult with local authorities to ensure compliance with all applicable codes and regulations. Proper installation of EMT requires careful attention to detail and a thorough understanding of the NEC and local codes. By following these guidelines, electricians can ensure the safety and reliability of electrical systems.